So we just talked about the sort of idea of defining what the momentum of a system of particles are, or what the momentum of a particle is. Right? So we said that the momentum for a given particle is simply the mass of the particle times the velocity of the particle. And the momentum for a system is just the momenta of all the particles inside the system added up. Okay? So we've introduced that idea. In this video, I want to introduce a couple of sort of key concepts here. One is the idea that momentum depends on what your frame of reference is. And the second idea is the connection between the idea of momentum and the idea of abstracting to a particle. Okay, so let's start with that first idea. What does momentum depend on? And let's sort of take just a particle and think about what momentum depends on. Well, it's pretty obvious what momentum depends on if you look at the expression. One thing it depends on is mass, right? And the other thing it depends on is the velocity of the particle. Kind of stupid, right? It already says that up there. But these are actually different quantities in an important way. Mass, as long as we're in the Newtonian, the world of Newtonian physics, mass is the mass of a particle is the mass of a particle is the mass of a particle. The mass is a sort of invariant quantity. It's constant for a given particle, right? So an electron always has a given mass so long as we're in the Newtonian framing of physics. On the other hand, velocity, if you think about it, is something that actually depends on where you're measuring from. So this depends on your, how do you spell your point of view, right? And when I say that, all I'm saying is that if I sort of imagine a baseball, this is supposed to, that's a baseball. If I'm standing here, right, and someone throws that baseball and I'm watching the baseball go by, I would say, aha, the baseball has a velocity to the right. So the stationary observer maybe says the velocity is 20 meters per second to the right. Right? On the other hand, I could equally imagine someone driving by in a car, right? And if that car is traveling along at 20 meters per second, what does the observer in the car say? Well, the observer in the car says, I can see this baseball outside my window, and the baseball at this particular instant has no velocity in the x direction. So the moving observer says 0 meters per second to the right. Now, it's true that both observers would agree that at some point the baseball was traveling up and at some point the baseball was traveling down. In fact, they both agree about what the vertical velocity of the baseball was at any time because both observers have 0 velocity in the y direction, but they're going to disagree about what the horizontal velocity is. Okay? So it's sort of one important idea here, which is the idea that the actual value of the momentum depends on your reference frame. And the people in different reference frames will disagree about what the momentum is. On the other hand, people in different reference frames will still agree about what the rate of change of the momentum is. Okay? And that will be true so long as that reference frame is what's called an inertial reference frame, or a reference frame that's traveling at constant speed. And I think I'll just stop at this point here with just this one idea that when you calculate momentum, you need to be clear about what reference frame you're in. It's a fairly obvious idea, but it's actually one that gets people into trouble a little later when we start to talk about torque, because in both in momentum and in angular momentum, your choice of coordinate system, your choice of reference frame ends up mattering. That doesn't change the physics, but it does change how easy it is to do the physics.